This demonstration shows how various of the Agile software engineering practices come together and support each other in the day-to-day activities of a Scrum team developer. What I'm going to show specifically is test-driven development, Agile modeling, programming by intention, refactoring, and emergent design. We're going to demonstrate how to write a piece of software that can score standard 10-pin bowling. In bowling, a game consists of 10 frames. In each frame, the bowler has 2 chances to knock down all 10 pins. The score for the frame is the number of pins knocked down, plus any bonuses for strikes and spares. A spare is when the player knocks down all 10 pins in 2 rolls. In that case, the bonus is the number of pins knocked down by the next roll of the ball. A strike is when the player knocks down all 10 pins on his first roll. In that case, the bonus is the value of the total number of pins of the next 2 rolls of the ball. In the 10th frame, if he gets a mark, which is what we call getting either a spare or a strike, then he gets enough extra rolls to be able to calculate what his bonus is. So at the end, on that 10th frame, he could get, if he got a strike, he would get 1 extra ball. If he got a spare, he would get 2 extra balls. So you always end up with 2 or 3 rolls in the 10th frame. At the bottom, I've got a real bowling game score, and we're going to use that to verify that we've come up with the correct code at the end of this demonstration. So let's start with a little bit of modeling. So one thing that we might do is, let's assume like I've just been given this user story. I am going to do maybe a little bit of modeling just to understand the domain more. Help me understand what the entities are. And so I'm going to create, I believe there's a game entity that represents the bowling game itself. I'm also going to say that a bowling game is composed of frames. And I'm going to show that with a relationship. I'm going to call that relationship has. So we've got a has-a relationship, and that has 10. A game has 10 frames. And I'm just using PowerPoint. This also could have drawn on a whiteboard. It's really just a temporary document. We're just going to model just enough to fully understand our domain and maybe get an idea of where our design is going. So thinking about the entities, we know that the bowler will roll twice in each frame. And so I'm going to say, let's create a has-a relationship between frame and roll, and that it's either 1 or 2. And that holds true pretty much all the time, except there's this pesky little thing called the 10th frame. And the 10th frame is a different type of frame. In object-oriented software, we would say it's a subclass of frame, and so we're going to represent that as a inheritance type relationship between frame and 10th frame. And I'm going to draw that pretty simply, right? And using PowerPoint, right? Everybody in my team has PowerPoint. This type of drawing, this type of technical drawing doesn't require anything super complex. Okay, so we're just going to use the tools we have on hand. And that's also, has a relationship. And how many extra rolls do you get? You get it could be 0, and it could be up to 2 extra rolls. Okay, but no frame will ever have more than 3. Okay, so there might be a business rule in here that says, when we're adding frames, when we're adding rolls to frames, that no frame will have more than 3 rolls. Okay, so this helps me understand a little bit more about my domain and the entities that are in it. That's a good example of a static model. Let's do a dynamic model. And in a dynamic model, we want to show the interactions between entities. And in this particular case, one of my chief interactions is actually going to be between my user, and we're going to call him a bowler, and the game object itself. So let's do a sequence diagram. I'm just going to do a quick and dirty sequence diagram here in PowerPoint. In sequence diagrams, we show interactions between things, and we often call those messages. And so we're going to have to have some way to record how many pins were knocked down on each roll of the ball. So I'm going to call this message the roll message, and I'm going to say we're going to send in the number of pins knocked down. Now there's no real return value on this. It's really just a one-way message. You know, we tell the bowler sends this message over and over until we actually have an entire game done. Okay, but at some point we're going to want to know what our final score is. So there we're going to ask a different question. We're going to say, you know, give me the score. And here we actually expect a return value. And the game should return the actual score. So there's my dynamic model. And I'm going to refer to this from time to time, but I'm not going to assume that this is my final design, right? We could go off and we could implement classes for game, frame, role, and we could create a subclass of frame called 10th frame. But I'm going to practice emergent design. And the way that I practice emergent design is I only add code to satisfy the use of that code. And I'm going to use test-driven development to represent those uses of my system. Okay, and this is where we get the term test-driven development. I'm going to use the test to drive the design of the code. But this is still a valuable diagramming session because it helps me understand the domain a bit more. So I'm just going to put that off to the side, and I'm going to go to my IDE. And we're going to write this code completely test-driven. So to write this code in a test-driven way, I need to understand what the rules are for test-driven development. And the first rule is that you can't write any production code unless you have a failing test. The second rule is that you can write no more unit tests than it is sufficient to get the first failure. We're never going to have more than one failing unit test at a given moment in time. The third rule is once I've got that failing unit test, I need to add only the code to the production system that will pass that test. No more. I don't want to add any more code because then I'm just speculating about how we're going to use the system. And the final rule is that we're not allowed to refactor unless all of our tests are passing. And if all of our tests are passing, we must refactor. Okay, so let's take those rules and let's try to build out our bowling game score system. Okay, so the first thing I have to do is I can't add any code unless I have a failing test. So the very first thing I must do must be to create a failing test. So I'm going to go into my IDE and I'm going to ask it to create a unit test case for me. I'm going to name that unit test case using a convention that we use in Java and for JUnit, and that is it's a class that ends in the name test, and the rest of the name represents the thing that we're testing. So I'm expecting to test my game entity from my modeling session. All right. I want to make sure I put that in my test directory because I don't want the test code to go to production. My IDE will generate a test class for me, and it will add a hard-coded test failure to it. And you see down here in the bottom left corner of my IDE, down here, that we've got a red bar. It says one test case ran, and because it's red, it means that that test case failed. In the margin of my code, I can actually see why it failed. It says it failed because it's not yet implemented, and it must be just pulling that message from this hard-coded failure. So I have a failing unit test. Let's clear it so that we have a green bar. The easiest thing to do there is just to remove the hard-coded failure. I now have a green bar, and I have a successfully compiling test case. Okay, well, that's a test case? You might ask. There's no code there. We're not testing anything. This is kind of an important step in reality because what it actually represents is this is a test for my environment. Is my IDE running? Is it properly running the test every time I save a file? Did I properly import the JUnit library that allows me to write tests? If all of those things are true, then I should have a green bar right now, and I do. So what we want to do at this point is we actually want to start writing a real test of my domain, and we want to stop as soon as we have a failing test case. And for the purposes of this, a compilation failure is in fact a failure. And you can see that my IDE has just told me there's a compilation failure. What that is really telling me is that there is no class named game in my system. And I'm going to treat this compilation error as if it's a failing unit test. So at this point, looking at my rules, I have to add a little bit of production code to make this test pass. Okay? In this case, clear the exception. So, or the compilation error. So I'm going to, again, lean on my IDE. I call this leaning on my IDE. I'm going to use that to create my game class. I'm going to make sure it goes into the production source code, and I'm going to let the IDE create it. Right. So at this point, I now have my game entity, and I have a clean test, right? The compilation error is gone. So at this point, I want to start recording a game, okay? And if I look back at my modeling session, we'll see that we had a message between the bowler and the game called roll. And it passed as a parameter the number of pins knocked down. So this is how we inform the game how many pins were knocked down on any given roll of the bowling ball. So I'm going to use that knowledge, and I'm going to say that there should be something on the game entity called roll where we send in the number of pins knocked down. Okay, and I'm just going to toss a 0 in there for now. Okay, I got that compilation error again, so I need to clear that. That's a failing test. I do the minimum amount of code it takes to clear that compilation error. And when I save it, that compilation error should go away, and I'm back to a green bar. Now that I've got a green bar, I must refactor. You say, well, geez, there's almost no code there to refactor, but really there is. I've got this method called roll on my game object, and it takes in this parameter. This parameter right now is mysterious. If I'm reading this code, I don't know what I stands for. I might have to read the content of this method and maybe other methods to ever understand what I represents. So instead of leaving it that kind of mystery, let's just rename it so that it represents something that we understand. So what if it was renamed to pins knocked down? Okay, well, that matches what I did over here in my Agile Modeling session, and that's entirely intentional. Okay, we want that to communicate to someone who's looking at this class what this method is for. So now we can say that the roll method takes the number of pins knocked down. So there we're using refactoring to do programming by intention. You can now clearly see the intent of what I meant when I wrote this method. Okay, so I've got a green bar. I've also have refactored the production code. I come back over to my JUnit class. I look to see if there's anything here that I can refactor, because we refactor test code in exactly the same way and for exactly the same reasons that we refactor production code. We want our test code to be readable, maintainable, extendable, etc. So I want to continue with my test, and at this point I'm kind of ready to think about what I'm really testing. I think I want to test the most trivial use case I can imagine. And for me, that would be where there was a 0 game, okay? Every ball missed all of the pins, okay? And I'm going to say, let's loop over all 20 rolls of the ball. And for each roll of the ball, I'm going to say we rolled 0, which in the bowling domain, that's called a gutter ball. And right now, this is not even a test. And the reason why it's not a test is because we don't check the production code for behavior. So I need to add in some kind of a check of the production code's behavior here and verify whether it passes that check or not. So we're going to add an assert, and we're going to say that we're expecting this game's score to be 0. And what I'm actually doing in the test is I'm writing the code that I wish existed. Okay, so I really want there to be a method called score, and I decided on that method because when I went back to my diagram, I saw that I asked the game for the score, and so let's just use that term from our domain as the name of this method. We're going to call score on game, and we're expecting it to return the actual integer value of the score. Again, I've got a compilation error. Let's do the simplest thing that would allow me to get past that compilation error. I'm going to make it return -1, and now I've got a red bar down here. I've got a failing test. I look at it, it says it was expecting 0, but it really got -1. I'm at the point where I've got a failing test. I need to write the smallest amount of production code that would make the test pass. And let's just make it pass by putting a 0 into that method. I've got a green bar. That test is now passing. I need to take a step back and see if there's anything I can do to refactor the production code. And no, not really. It didn't even really change. Can I refactor anything about game? And when we were having that discussion about rolling a 0, and we call that a gutter ball in bowling, it's a good practice for us to use our domain terms in our code. So I'm going to extract that as a constant, and I'm going to name that gutter ball. I could refactor the name of this method. The name of this method is not communicating anything to the other developers who might be reading these test cases. Maybe I should name it something that will communicate what this test does. So let's rename it to test gutter game. And we can see every time we do a refactor, we also make sure that our bar stays green. That's why we do not refactor unless we have a green bar. That makes sure that we didn't break anything inadvertently. So let's add our next test. Now that we're back to a green bar, we don't have anything else that we feel like we can refactor. Let's add the next test. So I'm going to call this we're going to test the no mark game. So again, I'm naming this meaningfully, and I'm using names from my domain. I'm not using technical names, I'm using business names in my code. And if we really want to check that we're actually doing the sum of different rolls, then we're going to need some different rolls other than 0. So let's say we knock down 4 pins, then we knock down 3 pins, and then we rolled 20 gutter balls. Nope, we rolled 18 gutter balls because we've just finished 1 frame out of 10. What would be the score of this game? The score of this game would be 7. When I save it, I get a test failure, and we're saying we're expecting 7, but we're getting 0. Each of these tests are looking for different values. That means we actually have to do some calculation in the production code. So the test is driving me to do the calculation. Well, what would be the easiest way to do this calculation? Well, I'm thinking right now that we could probably just keep track of the sum of all the pins knocked down. Okay, and I'll just save that as a field in the class, and I'll return that from my score method. Oh, look, my test is green now, and that must mean that this test is passing. I have a passing test case again. I must refactor. And I'm really thinking about it for a minute, and maybe sum isn't the best name for this variable. It is a sum. It's the sum of all the pins knocked down, but it doesn't, the name sum itself doesn't really tell me anything. In my domain, I'm calculating this sum to determine the score. And in fact, in my score method, I'm just returning sum. So really, sum is really just the score. So let's just rename it to score. One of the reasons why you might refactor code is to remove redundant code. That reduces the total amount of code in your system, and that's always a win. Okay, less code is better than more code. All other things being equal. And if I look at these two test methods, both of them create games, and both of them have this loop in it. And really, the only difference between this loop and this loop is how many times we iterate over it. So I think we can get rid of some redundancy in this by, first of all, I'm going to turn game into a field of the class, and then I can get rid of declaring it in each of my test cases. And then secondly, I'm going to look at these loops and say, you know, if this value was parameterized in some way, they would be exactly the same. So let's just kind of fake parameterization here by extracting a local variable. I don't even really care what it's called at this point. I'm also going to do the same thing on the other loop. Okay, I'm going to extract a variable from it. And again, I don't really care what it's called at this point because I'm mid-refactor. Now, at this point, these two loops now are, in fact, exactly the same. So what I'm going to do is I'm going to highlight that code, and I'm going to tell my compiler, let's turn that into a method. And I could have done this manually, but I'm leaning on my compiler. I'm leaning on my IDE to do this stuff for me. I'm going to call this roll mini gutter balls. And I know that I really want to be more communicative, so I'm going to say number of rolls. That's the name of the parameter to this method. Now I can inline those temporary variables and get rid of them to shorten the code even more without losing any of its readability. Let's add our next test case. Our next test case, what do you think would be the most interesting one to add? What's the next simplest one to add? You know, if I look at my rules of bowling, it talks about only really 3 cases where you don't get a mark, where you get a spare, or where you get a strike. So let's just test spare. Okay, and let's just test the case where we have only a single spare in the entire game. And again, I'm going to copy some existing test code. So for spare, the total of the 2 balls in that first frame should equal 10. Okay, and then to calculate the bonus for the spare, let's give it another valid. Okay, he rolls 7 balls there. And then there would be 17 gutter balls left to roll to complete a game. And then we have to figure out what the score is going to be. It's 24. Okay. When I say that we have a test case failure, we know that because my bar turned red, and if I hover over the error, it says we were expecting 24, but it was 17. So now I need to come over to the production code and add just enough code to make this test pass. And really, if I'm kind of going with the pattern I've already established, then I need to put that code in roll. And what roll would want to add is something like, you know, if pins knocked down plus the value of the last ball equals 10, then my score is incremented by 10 plus the value of the next ball. So I'm kind of doing it in pseudocode right now, just so I can kind of feel it out, you know, a little bit. And when I start thinking about implementing this, I'm thinking to myself, well, roll really only knows about the current number of pins knocked down. If we need to remember the value of the last ball, we're actually going to need to be able to save that somehow. So maybe at the bottom of roll, we record the value of the last. Let's call it roll because that's the term that we were actually using. And then we could say, you know, put the pins knocked down in that. And then we could put that as a field in my class. And I could turn this like that. And then I have to, well, now to make this work, I actually have to know what the value of the next ball is. And this is getting really complex. Maybe it's complex because my design is wrong. If my design is wrong, how could I improve it? You know, one of the things that I learned in Agile Software Engineering was there were 3 rules about interfaces. And the first rule was that each method of the interface should do exactly what it tells you it does. If I think about that for a minute, and I think about these methods on game as being my interface for outside code to use the game entity, then role really sounds like, you know, let's look at how I use it, okay? I basically say I rolled a 4 on this roll of the game, and in the next roll of the game I rolled a 3. There's nothing in that that implies calculation. It really sounds like we just want game to remember what the rolls were. So maybe instead of trying to make roll calculate the score, maybe all that roll should do is remember the roll that we made. Okay? And if that's the case, then maybe score sounds more like something that might calculate something. So maybe we should move all of the calculation down in the score. But that's a big refactor. How would I do that? I can't refactor because I have a failing unit test, and we can only refactor when the bar is green. So, you know, first of all, let me get rid of all this speculative code and all of this pseudocode that I put in there. Let's get back to where we were. How do we get rid of this failing unit test so that we can refactor this production code? Well, JUnit gives me the ability to disable a test. And so I'm just going to temporarily disable this test. That gets me back to the green bar. Now I can start refactoring it along the ways that, you know, I just described, so that roll actually remembers the rolls that were made and score does the calculation. So if roll is going to remember the rolls, then he needs some way of storing it. I'm just going to pick an array. And what I'm going to do is I am going to have the compiler create this field for me, and we're going to, on my IDE, I'm going to, there's a maximum of 21 rolls in a game, and I'm going to need to keep track of which roll that we're currently on, and so that's what rolls index is. And so now roll is purely just remembering what the rolls were, and score, we want to calculate the actual score. So instead of score being a member, a field of game, let's just make it a local variable. And we're going to start at 0, and what we're going to do is we're going to walk over that array, and for each value in the array, let's increment score. So what I'm really doing is I'm taking the sum of all the pins in the array. Okay, and let's return that value. And if I've refactored this right, I've got a green bar down here. Okay, great. So now I'm ready to start thinking about spare again. Now that I've got the responsibilities in the right place, how would I track spare? And if I do a little bit of thinking and maybe write a little bit of pseudocode, I'll realize that I've got another problem. If the way I'm going to calculate it is to run through every roll one by one, then detecting a spare becomes a little bit of a problem, because these two would be detected as a spare because they add up to 10. But if I had rolled 4 here as well, then the last roll in the first frame and the first roll in the second frame also add up to 10. And that seems to me that, you know, this code would naively detect that as being a spare when it's not. So maybe what I really need to do is, maybe instead of walking through all the rolls one by one, maybe I need to walk through the list of frames one by one. So let's change this such that we're going through all 10 frames, and for each frame I want to add up the 2 balls in that frame. So I'm actually going to need another index into the rolls array that I'm using here. So I want to say the score is roll index. That's the first roll of the current frame, and roll index plus 1 is the second roll in the current frame. And then we want to increment roll index by 2 because there's 2 roles in each frame, at least in the code that we have today at this moment in time. And if I look over here, I see that that works. So these 2 test cases are working now that we have rewritten things to be based on the frame. But I'm back to a green bar. So I need to think about refactoring. What can I refactor to make, how can I refactor to make things better, more readable, reveal the intent of the programmer, et cetera, et cetera. So one thing is it may not be immediately obvious to other developers that what I'm doing is walking through the list of frames. Okay. Maybe we ought to make that explicit. So let's rename this variable. Let's call it frame index, and that ought to give the other developers a clue. And unless you know the domain really well, you may not know why I chose 10 here. It's a magic number. In this case, it represents the number of frames in a game. So maybe we ought to extract that as a constant. And we're just going to call it frames in game. Again, why name it something? Why make it less obvious? Let's make it as obvious as possible. Okay, so now when another developer reads this, I think he's going to understand that we're walking through all of the frames of a game and we're calculating the score. If I go back to my domain and I look at the rules of bowling, it said that the score for a given frame is equal to the sum of the pins knocked down by both rolls in that frame. Maybe I could even help the other developers out a little bit more by extracting this thing as a method and giving it a name like, I don't know, sum of pins knocked down in frame. Let's move on with actually trying to do our spare. Okay, so we got a failure. We were expecting 24, but we got 17. I think we're set up in a good place now to try to handle the spare. So I'm going to tell the other developers that this mysterious code that I'm about to type is actually handling the spare. So what I want to do here is I want to say that if the 2 roles in this frame equals 10, then that's a spare. And I want to go ahead and capture our non-spare code, make sure we're not calling it in addition to the spare code. Then what is the score for spare? The score for spare is 10 plus the bonus for a spare, and we say that the bonus for a spare is the next ball we're going to roll. Okay, so that would be at index. That would be at index plus 2, and we want to increment our index appropriately. I'm using roles index there. There we go. There was a little bit of a bug. Oh, look, there I'm at a green bar. Okay, so I think there's a potential of confusion between roles index and role index that I'm using here. So maybe I should rename this one. Let's rename it something like input roles index. And I'm not going to make that mistake again. Okay, so I've got a green bar. My spare game is passing. My no mark game is passing. My gutter game is passing. Let's take a moment and see if there's anything we can do to refactor this production code. And in fact, okay, I'm kind of relying on this comment to let the developer know that this is checking for spare. But I actually have the ability to maybe make that even more obvious. I'm going to extract that as a method. And I'm going to name that method is spare. Now this comment becomes unnecessary. And there's another name for comments in code, and that word is lies. Comments go out of date with the actual code because there's no force that forces the developer to update the comment when he changes the code. And so most comments that you see in code are probably wrong if the code has gone through any changes. So what's better is to use the code to comment itself. There's no reason to put a comment to say this is the spare case over this code, because the code says is if this is a spare. Okay. Now our rules say that the bonus for a spare is the value of the next ball. So maybe we should reflect our domain and we should call this bonus for spare. Okay. Still got a green bar. Always check your green bar after you refactor. Look at our test code. Anything to refactor here? I don't see anything to refactor here. So let's add the next bit of complexity. What's the next simplest thing that we could test? We're pretty close to the end of our list of the rules of bowling. The only thing that it actually mentions that's left are strikes. So let's do a strike game. Okay, and we're going to mostly do the same steps here. There's some types of repetition you can't get rid of. This is an example of that. And in this case, right, we want to roll a 10, and that's a strike. And then we want to roll something that gives us a bonus. So let's say that it's, we'll go ahead and roll the 6 there and a 1 here. So we got a total of 7 in the second frame. We know that the score for a strike equals 10 plus the value of the next 2 balls. And we know that the value of the next 2 balls are 6 and 1. And therefore, our first frame, our score is a 17. In our second frame, we add 7 to that. That's also a 24, but we're only going to roll 16 more balls. I have a test failure. I was expecting 24, but it was really 17. And again, not surprising, we have no code that actually detects strikes. So what is a strike? A strike is when the current frame first ball knocks down all 10 pins. Okay, and that should be rolls. And that's a strike, right? And our score for a strike is 10 plus the value of the next 2 rolls. So the next 2 rolls should be those 2 things, and we should increment roll index by 1. Now look, we have a green bar. So our strike game must be working. Let's look and see if we have a chance for refactoring. And along the same lines as we had before, we're going to refactor by extracting out my check for strike into a method that's just called isStrike, and that removes the need for this comment. It is intentional programming. I'd actually like for this code to reflect our approach for spare, and I want to change it into the bonus for a strike. This is just slightly more indirect using the IDE, and I have to extract that out as its own variable, and then I can extract it as a method. I'm actually not sure why it can't detect that I could extract that as a method without having also extracted it out as a local variable, but that's the way it is. Let's call it bonus for strike. And then we can inline this variable and get rid of it in our code. Okay. So everything at this point is working. I am proposing that I've passed all the tests. My code must be complete. But maybe I don't really know that unless I were to test that sample game that we had, right? And if you recall, that sample game looked like this, and it has an expected score of 187. So let's try to see if we can't get that to work. So what I've done, just to save some time, is I saved off all of the record of the various rolls that the bowler made in a comment. And now let's turn it into code. And here's the moment of truth. Will score return 187? When I hit save, it should return, it should stay green. The bar should stay green. And in fact, it did. So we have successfully completed our user story that creates the code that scores 10-pin bowling. And if we look at it, I'm hoping you agree with me that this code is very readable and understandable. To a programmer, it almost reads like the actual rules of bowling, in which it says to calculate the score for a game, we need to go through each frame. If that frame is a strike, then the score is incremented by 10 plus the bonus for a strike. Else, if it is a spare, the score is 10 plus the bonus for a spare. Otherwise, it's just the sum of the pins knocked down in the frame. Okay, so that looks pretty good to me. I don't think I really need any comments on this code at all. The other thing that I want to point out at this point is that we allowed this design to emerge. This is Emergent Design. The only forces we put on this were on the code itself were the test cases. We had done this Agile modeling thing where we had entities for frame and roll and 10th frame, and we don't see them in our solution. Does that mean that our solution is wrong? No. Does that mean that our modeling is wrong or unnecessary? No. This informed me, helped me keep track of what it was I was building, and it serves as a possible future state of my game class. We may add in the future other uses of the game class that require us to extract the frames out as their own entity. But there's no reason to do that until we have that use case. This way we keep the code as simple as possible, and it's the only complexity in this code are to directly address the test that we wrote to verify that it's working. And that is test-driven design. That is truly test driving the design of the code. Okay, hopefully you saw how test-driven development works. You saw how Agile modeling helps you get a grasp of the domain and give you a potential model for what your design might look like. You saw programming by intention, in that I revealed my intention at every point along the way by refactoring and renaming things. And so therefore we had to use refactoring to do that. And finally, emergent design. We don't jump to the final, what we think is the final design up front. We allow the design to develop test case by test case, story by story. It might eventually look like the thing that we sketched, but we don't force it to look like the thing that we sketched at the beginning.